Before we end this, let's just recap some of the things. So we have the situation that the breadth first search and the depth first search give us spanning trees of our graphs. So it gives us a subgraph, which is a spanning tree. So the depth first search and the breadth first search both give us spanning trees of our original graph. So it's a subgraph, which is a spanning tree. They are both transversal algorithms. In other words, they're moving through nodes, transversal. And what they do is, the differences is the one is going to search via depth first, and the other one is going to explore level by level. So it is going to look at all the branches at the next level, all the branches at the following level, and so on. So let's just write that down. Okay, so those are where the depth and the breadth comes into play, because the depth, it keeps on going down as far as possible, so it covers the depth through the grasp, whereas the breadth first search, you start at the root and you look at everything in the next level to it, as close as possible basically to the root, and you move on from there. Okay, some of the other things that are different is with the depth first search, you are going to follow the path down. So you're going to go through the depth and then you're going to backtrack. So once you hit a point of no return kind of a thing, you're going to backtrack and then look at the search again from those points. Whereas the breadth first search, you are going to cover all those nodes as you go on. So by the time you get to the end, there is nowhere else to go. You have covered all your nodes. The breadth first search, you visit all those nodes and you go through. So there's no backtracking essentially there. Okay. Some other things, the depth first search finds a path, usually a long path kind of a situation. So it finds a path as you're doing your whole spanning tree situation, whereas your breadth first search, it's really finding the shorter path. So something we will discuss further next week or so, or the week after, is regards to the shortest path. And because the depth first search finds a path and just goes down like a straight line situation, it tends to be faster, whereas the breadth first search computationally tends to be a bit slower because of the idea that it has to look and store all those active nodes, vertices, and move on from there. So again, not that applicable right now, but will be applicable in the future. And then just a last thing, because you're probably wondering about this, you're like, okay, sweet, I can find a spanning tree using either the depth first search or the breadth first search. And now I'm starting to see that we're going to use it elsewhere, but let's just bring this into the idea behind it, or where exactly we're going to be applying these things. And that is, your depth first search is more for a situation of, you just want to find out if something is connected. So you don't really need a lot of information on it. You just want to find out it's connected. Or you have a maze and you just want to find the maze situation. Whereas your breadth first search is going to be used more for seeing exactly how connected your components are, because you have those branches, situations, and also the shortest path, which is something we pointed out already. And also for the situation of, again, going back to the connectedness, if you had to activate your whichever vertice, by activating that vertice and then looking at, the process from that point, again, you're looking at how connected is that vertice to all the other nodes in the graph. So again, it's going to measure connectedness, particularly in regards to that. So the depth first search is more for just finding that the components are connected. You don't really care how connected they are to each other. You just care that they're connected. And for things like a maze, where you just need to solve to get to the end situation, whereas your breadth first search, because of the way it's structured, you can find out more information about how connected that node is, or what is the shortest path from that node kind of a situation. So depth first search, solving mazes. There are obviously a bunch of other uses for it. I'm only just looking at a few simple examples. Finding out they're connected. Components. And the breadth first search, your shortest paths. and how connected, etc.